The moon has been staring down at us for 4.5 billion years, and we still don't really know what it is. Not the side we see every night, that one we know reasonably well, but the other side, the side permanently turned away from Earth. The side the Artemis II crew just became the first humans in over 50 years to fly over and photograph up close. Because here is the thing, in the last 2 years alone, through a combination of China's historic sample return mission, brand new research published in Nature, and the observations just made by the Artemis II crew, the far side of the moon has gotten dramatically more mysterious. Not less, more. Scientists thought they were closing in on answers. What they found instead are deeper questions, and some of what they found is genuinely difficult to explain. This video is going to take you through all of it, every real discovery, every real mystery. And by the end, you are going to understand why the far side of the moon might be the most scientifically important place in the entire solar system right now. Hit like if you want to see more videos like this. Let's go. First, let's deal with the name, because it matters. Most people call it the dark side of the moon. Pink Floyd made that phrase famous. But it is technically wrong, and understanding why it is wrong is actually the first clue to understanding what makes the far side so strange. The moon is tidally locked to Earth. It rotates at exactly the same rate it orbits our planet, so the same face always points toward us. Always. The far side is not dark. It gets just as much sunlight as the near side. 2 full weeks of blazing daylight followed by 2 full weeks of darkness, same as anywhere else on the moon. When people call it the dark side, they mean dark as in unknown, unseen, hidden from every human eye that ever looked up at the night sky. For the entirety of human history, until 1959, when a Soviet probe called Lunar 3 swung around the moon and sent back the first blurry photographs of what was there. What those photographs showed, and what every subsequent mission has confirmed, is something that has puzzled planetary scientists ever since. The far side looks completely different from the near side. Not slightly different, not kind of different. Shockingly, almost impossibly different. And nobody, even today in 2026 with all our technology and all our data, can fully explain why. Here is what the difference actually is, because you need to understand it to appreciate how deep the mystery goes. When you look at the moon with the naked eye from Earth, you can see large, dark patches. Those patches are called maria, from the Latin word for seas, because ancient astronomers thought they might actually be oceans. They are not oceans. They are vast plains of solidified lava, ancient basalt that erupted from the moon's interior billions of years ago, flooded enormous low-lying basins, and hardened into flat, dark plains that cover about 31% of the near side's surface. The near side also has a relatively thin crust, relatively low elevations compared to the surrounding terrain, and it is rich in a specific set of heat-producing radioactive elements, a geochemical mixture scientists call creep, potassium, rare earth elements, and phosphorus, that generated enormous amounts of internal heat, drove volcanic activity for billions of years, and created those dark plains we see every night. Now look at the far side. Only about 1% of the far side is covered in volcanic maria. 1%. Versus 31% on the near side. The far side has a much thicker crust, higher elevations, almost no evidence of the prolonged volcanic activity that shaped the near side. It is relentlessly, overwhelmingly cratered, impact upon impact upon impact, preserved in extraordinary detail because almost nothing volcanic ever resurfaced it and erased the record. The 2 hemispheres of the moon form together. They are made of the same basic material. They have been sitting in space for the same 4.5 billion years, and they look like they belong to different worlds entirely. Scientists have a name for this. They call it the lunar dichotomy, and it is one of the biggest unsolved mysteries in planetary science. As one planetary scientist at the University of Arizona put it, the moon is lopsided in nearly every respect, and we don't know why. For decades, without samples from the far side, scientists could only theorize about what was causing the dichotomy. The leading theories were interesting but unproven. Then, in June 2024, China did something that changed everything. The Chang'e 6 mission landed in the Apollo Basin, inside the largest impact crater in the known solar system, the South Pole Aitken Basin, on the lunar far side. It scooped up 1,935 grams of lunar soil and rock, and it brought those samples back to Earth. For the first time in human history, scientists had physical material from the far side of the moon sitting in a laboratory. What they found when they analyzed those samples was not what they expected, and it has generated an avalanche of new research, with papers published in Nature, Nature Geoscience, the National Science Review, and other major journals throughout 2025 and into 2026. Here is what the Chang'e 6 samples revealed. Discovery 1. The far side mantle is colder, and the difference is bigger than anyone realized. Scientists already knew the far side had a thicker crust. What the Chang'e 6 samples confirmed for the first time using actual rocks is that the difference between the two hemispheres extends far below the surface, deep into the moon's interior. The basalt fragments in the Chang'e 6 samples are 2.8 billion years old. Researchers analyzed their chemical composition to reconstruct the temperature at which the lava that produced them formed, deep in the moon's mantle. The result? The far side mantle formed lava at around 1,100 degrees Celsius. That sounds extremely hot, and it is. But near-side mantle rocks suggest temperatures of around 1,200 degrees Celsius. That is a 100-degree difference. In the context of planetary geology, that is enormous. The lead researcher from UCL who co-authored the study put it simply: it is one of the great mysteries of the moon. A dramatic temperature difference between the near and far side mantle has long been hypothesized. The Chang'e 6 samples provide the first evidence using real rocks. The differences between the near and far side are not only at the surface, they go deep into the interior. This is significant because it means whatever process created the lunar dichotomy did not just affect the crust. It affected the entire internal thermal structure of the moon. Something happened 4 billion years ago that permanently and fundamentally altered one hemisphere relative to the other, all the way down. The question is, what was it? Discovery 2. A 4.25 billion year old catastrophe may have shaped everything. The South Pole Aitken Basin, the crater where Chang'e 6 landed, is not just the largest impact crater on the moon. It is one of the largest impact structures in the entire solar system. It stretches approximately 2,500 kilometers across. It is about 8 miles deep. It was formed 4.25 billion years ago when something enormous hit the young moon. New research published in Nature in late 2025, led by scientists at the University of Arizona, proposed something remarkable. The impact that created the South Pole Aitken Basin did not just leave a crater. It may have fundamentally reorganized the moon's interior and created the lunar dichotomy. Here is the theory. When the early moon first solidified from its initial molten state, a global magma ocean covering the entire surface, heavier elements sank toward the interior, while lighter elements floated to form the crust. The heat-producing radioactive elements, the creep material, were left over at the end of this process, concentrated in a thin layer sandwiched between the solidifying mantle and the crust. Nobody fully understands why this creep material ended up concentrated on the near side rather than being distributed evenly. That has always been the central unanswered question. The new research suggests the South Pole Aitken impact provided the answer. The massive asteroid that created the basin struck the moon from the north, moving southward. The enormous heat generated by that impact, temperatures that would melt rock on a planetary scale, vaporized and redistributed material across the lunar surface asymmetrically. The creep-rich material got pushed toward the near side. The near side heated up, its crust thinned, volcanic activity intensified, dark plains formed. The far side, meanwhile, was left depleted of heat-producing elements. Its crust thickened, its interior cooled faster. Volcanic activity never really got started or ended much earlier than on the near side. One massive impact 4.25 billion years ago, and it may have determined everything about how the moon looks today. The Chang'e 6 samples helped confirm this by revealing a specific chemical signature. The samples from the northeastern part of the basin are low in creep material, but the southwestern part of the basin, the area pointing toward where the impactor came from, shows elevated concentrations of thorium, a radioactive element tightly linked to creep. This chemical divide across the basin is exactly what you would expect if the impact came from the north and pushed the creep material toward the near side. The study's lead scientist said it directly. The Artemis missions will be landing on the downrange rim of the basin, the best place to study the largest and oldest impact crater on the moon, where most of the material excavated from deep within the moon's interior should be piled up. Discovery 3. Something enormous is buried inside the biggest crater in the solar system. This is where the story becomes genuinely strange. Inside the South Pole Aitken Basin, this enormous impact structure on the moon's far side, there is something buried, something large, something dense, something that nobody fully understands. Scientists using NASA's Grail mission, which mapped the moon's gravity field in extraordinary detail, discovered a massive anomaly deep beneath the basin floor. Not a small anomaly, a giant one. The excess mass extends to depths of more than 300 kilometers below the surface. One of the scientists involved described the scale of it this way. Imagine taking a pile of metal 5 times larger than the big island of Hawaii and burying it underground. That is roughly how much unexpected mass is sitting beneath the South Pole Aitken Basin, and it is weighing the basin floor down. The floor of the crater is being pulled downward by more than half a mile, 0.8 kilometers, by whatever is sitting beneath it in the mantle. What is it? The leading theory is that it is the metallic remnants of the asteroid that created the basin 4.25 billion years ago. When the impactor struck, its iron-nickel core may have been partially captured by the moon's gravity, rather than bouncing back into space. It sank into the mantle, and it has been sitting there ever since. A foreign body from the early solar system buried hundreds of kilometers underground, slowly dragging the crust of the moon's far side downward. If that is what it is, then the South Pole Aitken Basin is not just a crater, it is a tomb, the burial site of the asteroid that may have changed the entire geological fate of the moon. The alternative theory is that the mass is an accumulation of chemical compounds, dense oxides that settled during the cooling of the basin's impact melt sheet. But scientists themselves admit this seems like an unlikely coincidence. A mass that large, sitting directly beneath a massive impact site, is a lot harder to explain as a coincidence than as a consequence. Either way, something enormous is down there, and we cannot get to it. Not with current technology. Not without drilling hundreds of kilometers through solid rock. Discovery 4. The far side had its own volcanic history, and it does not match the models. One more finding from the Chang'e 6 samples that has not gotten nearly enough attention. Scientists expected the far side to have almost no volcanic history. The assumption was that without creep and its heat-producing elements, the far side interior simply never got hot enough to produce significant volcanic activity. The samples proved that assumption incomplete. The Chang'e 6 basalts showed evidence of volcanic eruptions on the far side in 2 distinct phases. One phase around 4.2 billion years ago, very early when the moon was still extremely hot from formation, and the South Pole Aitken impact itself may have provided additional thermal energy. And a second phase 2.8 billion years ago, far more recently in geological terms, long after most scientists thought the far side had gone geologically quiet. The question this raises is uncomfortable. If the far side's mantle was depleted in heat-producing elements, what was driving volcanic activity 2.8 billion years ago? Something was still providing thermal energy to the far side interior at that point, and we do not know what. One possibility is that the South Pole Aitken impact itself created a long-lasting source of heat deep in the mantle, perhaps through the buried metallic mass, which could have generated heat through tidal interactions or radioactive decay. Another possibility is that the lunar interior was more complex and heterogeneous than current models suggest, with pockets of heat-producing material distributed more widely than previously thought. Neither explanation is fully satisfying. The far side volcanic timeline does not fit neatly into any current model of how the moon should have behaved. So here is where we are. The far side of the moon is not just different from the near side at the surface. The difference goes hundreds of kilometers deep into the interior. Something struck it 4.25 billion years ago with such violence that it may have permanently reorganized the moon's internal chemistry. There is a buried mass beneath its largest crater that we cannot fully identify or explain, and it had a volcanic history that does not match what our thermal models predict. And here is the part that makes all of this more than just academic. Artemis 4 is planning to land near the lunar South Pole, right on the rim of the South Pole Aitken Basin. If the theories about where the impact ejecta piled up are correct, the Artemis astronauts will be standing on top of some of the deepest material ever excavated from the moon's interior. Material that was blasted upward from hundreds of kilometers below the surface during that catastrophic impact 4.25 billion years ago. Material that could answer the question of whether the buried mass is an asteroid core or something else entirely. Material that could confirm or destroy current theories about the lunar dichotomy. Material that has been sitting there since shortly after the moon formed, waiting. The Artemis 2 crew flew over the far side on April 6, 2026. They photographed its impossible, relentless craters. They called it impossibly rugged. They described its colors, the browns and blues that no camera had ever captured from this distance the way human eyes could. They saw features that scientists have been theorizing about for decades. But seeing from 4,000 miles above is not the same as standing on it. Photographing from orbit is not the same as picking up a rock and handing it to a geologist. The far side of the moon has been hiding something for 4.5 billion years. Multiple somethings. The questions it is generating right now, with the best data we have ever had, using the first samples ever returned from its surface, are bigger than the answers we started with. As one planetary scientist said, we don't know why. The moon is lopsided in nearly every respect, and we don't know why. That is not a failure of science, that is science working exactly as it should. Every answer reveals a deeper question. Every sample opens a new mystery. Every photograph from a spacecraft window reminds us how much of this world we have not yet touched. The dark side of the moon, dark in the sense of unknown, dark in the sense of unseen, dark in the sense of ancient and preserved and waiting, just got a lot more interesting. And the people who are going to go down there and find out what is actually there are currently in training. Subscribe if you want to follow every step of this story as it unfolds. We are going to cover all of it. Stay curious.